Welcome to the Queen of Nanaimo's mechanical orientation. There's very little on the outside of the ship that actually needs going over, but I will call attention to the marks on her car deck flare, which align her to her cradle. It's very difficult to actually get her on her cradle if you don't know where, and that will show you exactly where. Next, we will go and lift off her superstructure, which sounds like a really scary thing, but it isn't. The superstructure was designed from the very start to actually lift this way. So it's structurally built to do this, and it's actually quite simple. First, we'll take the funnel off, and that we do very simply. It's put on with 3 magnets. It's you just push it back about 1 inch. It releases the magnets, and off it comes. And you'll notice underneath there's the aerial. And the aerial slips into a sleeve and then slips out. And we can just drop that through the funnel, like so. And the funnel is off. Now, her lifting jig is set up for her. It's got the correct center of gravity and everything. And it just goes up on the deck. We put it down in front of the lifting rings, and we draw it back like so. We just draw that into the lifting rings, and it's precise for both ends. And now we are actually ready to lift. There are no mechanical fasteners in the superstructure to hold it down. It weighs plenty, and the fit to the hull is very precise. It's very tight, and it doesn't shift around, it doesn't move back and forth, and it doesn't readily want to pull off. So it uses its own weight to stay in place. Now you'll notice what I'm using here is a little Princess Auto crane, a winch with as much speed reduction as possible. And that's really the nicest way to do it because you have a huge amount of control. Any taking it off by hand is going to be difficult and dangerous because you really want to bring it back on, especially. Taking it off, not so bad, but putting it back on, you really need the control to just drop it down in place. As I said, it fits very precisely. So we're going to drop down. And hook on, and they all look good. And when we're lifting up, we're just going to take the slack out, put a little bit of force on it. Just a little bit of force. And the most important thing to this right now is you go back and check every single one of these to make sure that they are actually hooked on. And that one you could actually hear pull in a little bit tighter. If they're all hooked on, this will not fall off. And that's why we go very slowly anyway. Okay. Just a little wiggle. If something doesn't want to lift at one end or the other, and it can be either, she's just a little snug. So just a little wiggle and off she goes. Now at this point, lift her up about 2 inches and check visually all the way through. Okay, and you'll see we still have the aerial line, which we'll pull back through. And now you can see we're completely free. Now, we're going to move this across, and we're going to put it onto a flat table. And the flat table has little risers, and these are 3/8 MDF because the side skirt on the actual superstructure comes down over the hull. And we need that to keep her from resting all her weight on that side skirt. It's actually designed that the interior walls are bearing all the weight of the superstructure. This would not bear weight, so that's why we use those. So right now, she's free, and we're just going to do the really scary thing, which isn't scary anymore. I'll unhook my cord. Okay, and we'll just let her down. And that looks really nasty, but it's very, very nice and easy. I'm just going to leave this hooked up. We're going to leave it so we can lift her back on in a few minutes. Now, going over our mechanicals, she's very advanced for a model, has a lot of features that a lot of models do not. There's room in here for two 45 amp hour 12 volt batteries. They would be done in parallel because it's all a 12 volt system. The wiring comes through past the motors and up into here, and our aerial also just lays in the bilge. Above all, remember to feed the aerial back up because it won't work very well in the bilge. So, okay, let's have a look at her motors and her grease, her greasing. Two 12 volt motors, they are belt driven into the shafts. One of these belts would probably be sufficient. There's lots of redundancy here, so no need for 4 belts at all, although there's 4 grooves. The propeller shafts are 1/4 inch stainless steel shafts through casings that contain 3 bearings that are oil impregnated bronze. And there's a middle bearing that's down here. And if you look at how the grease line comes in, it comes in and tees to both shafts. And then there's a minor line that actually pumps grease behind the other bearing. So all of the prop shaft spaces are satisfied by greasing with the extra little line there. If we follow the greasing line out, it comes back up into the car deck, and you'll see that it comes back up into the car deck, and it's readily accessible when the ship is in the water. The actual ship is designed that she could actually sit in the water for extended periods of time. You should always grease your shafts after it's been run, after your day of running, and before it sits. That reseals the propeller shafts from any possibility of leakage coming up the shafts. This is done as well as the charging port over this side for actually recharging her batteries. This is also accessible when she's in the water. So if this were to ever go to a major radio control meet, she could actually sit in the water for days on end without having to be pulled out. And she could actually be recharged, greased, and put back into service the next day without any problem at all. The underside of the propeller shafts, I want to point out that we have back in here, we have her standoffs, and we also have a thrust bearing. This is a water lubricated thrust bearing that takes the thrust from the propeller up the shaft and then back up into what is on this model the engine casing, and that is what puts the forward thrust into the ship. There's just a slipper bearing in reverse, and because it's probably not going to be used nearly as much. But again, meant to do a lot of miles, or capable to do a lot of miles. Now, if we're going to look at some of the electronics in here, we have these are the reversing switches, and they are actually on servos to double pole, double throw switches. That may seem a little archaic or not in, because you can get radio controlled relays, but this is extremely robust, and it's necessary because if you miss and actually are under throttle and throw the motors into reverse with a regular RC type relay, you can actually blow the relay by reversing them. This you cannot blow, it doesn't care. It also has a center off, which actually lets, for a very short moment, takes the power off the motor before it reverses. So it's actually very good on the motors, it's good on the electrical. It's very robust. Single direction speed controls on each motor, all wired in with plugs so they can actually be pulled out and replaced and put back in. In the machinery, or the actual control space here, we have a fuse block, we have the radio control receiver, and we also have what's called a buck, or a voltage reducer. So this voltage reducer should be set to 5 volts, which it is, and it actually powers the receiver. So there's no separate receiver battery. It all runs off of the ship battery. And there's great amounts of excess power according to the amount of power that those motors can use, that a regular pair of 45 amp batteries should last about 16 hours when in full use. So it can go quite a distance. Very simple, and it's built in such a way that that we have. Oops. It's built in such a way that we have a single switch runs everything, and you can tell that we have battery voltage LED and a receiver voltage LED. And when the superstructure's on, you can look up into the car deck, up into the overhead car deck, and actually see your voltages. And you can tell spot on very quickly. We want about 5 volts or 5.1, 5.2 volts on the receiver. And this is just what your battery will give. 12.7 is super. 12.2 is about the minimum. If you see your 12 volt battery is down to a 12.2, that means they'll be down to about 25%, and that's about as deep as you want to take them. Other than that, we do have the charging port right here. I have a charging pigtail that goes with it. And we also have the rear car deck in here. It goes up to a full watertight compartment, as this bulkhead here is full watertight. In other words, you could get completely swamped in here and it won't matter. It won't go into the motor spaces, it won't affect anything. Under this very accurately cut panel, we have access to the rudders, which under any normal circumstances except an accident or damage, you would basically from now on in never access. But here's our rudder stanchions and linkage. Okay, we just have a small battery in it right now, but I'll show you the radio. And radio is very straightforward. Of course, Naniamo colors, the original livery. We can, the ship is on, and we can, okay, that I'll explain. When you turn on the radio and it beeps and you get a little error here, It just simply means that something is not where it should be starting. So we actually had reverse on, and it doesn't like that. So, but once it's up and running, those are our reverses. So we have the ship's wheel, and obviously we can see that there's your steering control, and we also have throttle, two separate throttles, port and starboard, and we also have reversing, and like I said, if you do it when she's running, nothing bad. Very simple, straightforward. There's still two proportional switches that are available. These two are actually still available, so there's the addition of lights or a bow thruster or whatever. They can go on this. So that's about it for her controls. She does have two left-hand spinning propellers, which will need trimming. That's a good and that's a bad, because traditionally you have counter-rotating propellers, but what it does do is it makes spare parts very easy. Because you have one propeller, you break one propeller, you'll probably always break the wrong one. One size fits all. It's really worth it. High impact plastic propeller, made by myself. The actual blade design is copied off the Normandy, and boy, do they ever move water. They are excellent, excellent. They have a lot of bite. So, let me review. In the car deck, greasing, charging, switch. In the engine spaces, grease lines, that's all solid state, that's good for life. Motors, they'll be good for life. And the reversing, that's our rudder servo. And she has a front watertight compartment, and as you can see, we have foam built into the hull on both sides. This is for the worst case scenario. You know, you can never be too careful. You always remember that one, the Titanic over there. So we have in volume about 2,500 cubic inches of foam, and that will pretty much keep her afloat even if she's holed, which would be virtually impossible to do because the hull is very robust. It's built like a canoe. It actually is. It's not thin, and no sparing the material, so it's very robust. Up at the front, we have a separate chamber. I put the foam across, actually built a separate chamber. This is where the anchors would go. The anchor holes are free. The actual mooring holes are all the way through. So if it ever got water up in here, it's all built to drain out and it can't go into the main hull. That, I think, basically covers the mechanicals of the ship. We will now lift back on the superstructure. Now we're going to put the superstructure back onto the hull and make her seaworthy. To do that, it's largely just a reversal of taking it off. And here, let me just take some slack out of the crane, and to do this, you can be on and off the switch a lot because you just want to get very, very little movement, not jerk the superstructure excessively or anything. We've got a little bit of tension on it. We're lifting our jig, and that way we can actually check all our positions again. We'll tighten it up a bit more. Getting a bit more force. we're all good. To guide it, I just put a thumb and a finger around the front railing because it's well balanced. I'm not actually lifting anything here, it's just a case of guiding it. And then I'll actually lift it across. I have the crane on rollers, we'll move it across. I bet you Dee's dock would love to have been able to do that when they lifted them. Take the aerial and up the main conduit to the upper deck. And I usually bring it across and just hook it through the railing because there's no force on it. The railings are actually fixed pretty well. And just want to make sure that the aerial doesn't disappear back down. We're all clear. Now we'll set the superstructure down. And what I like to do is bring it down close, bring the hull in, because everything's on wheels. Get the front down first. And if you need any adjustment, you just push or pull on the cart, and it'll swing the rear of the superstructure. And that looks like that's just about it. Not all the weight's down. Come back, check, make sure everything's nice and flat, it's not crooked. That's all the way. I'll just slide that across. This will just slide out. I usually don't slide it very far, as it'll score the paint up. Just lift it off and away. Next step, put the funnel back on. Hardest thing about the funnel is to put the aerial into it. You can hold the funnel quite easily, even with the mast on, which is off right now. You just slide your hand in between, nice hand hold. It's actually made out of aluminum and it's reasonably durable. Don't abuse it, but it's quite handleable. Put the aerial up through the back or the central cutout and line it up and look from below. You should be able to see it. Should be able to. There it is. And bring it up through the hole. Let's see. Grab it. It'll fit into its little slot, and when you push it down in there, it's fully affixed. And then we just take the funnel house, drop it on the top deck. You can look at our location decal right there. Bring it up to the off position, it drops into place. Slide it forward, and it's all held in place with the magnets. We're all ready to go. That pretty much does our summary of the mechanicals on the Naniamo and how to get in, work, and maintain her. Thank you very much.